Achievement. You can do anything you set your mind to when you have vision, determination, and an endless supply of expendable labor. Appropriate way to begin our, or a joke really, to begin our discussion and wrap up gears. So we're going to talk about gear design, but from a little bit lighter angle. Sort of a pun, I guess, because we're talking about plastic gears initially. And plastic gears are a thing now. They are possible. They're stronger than they used to be. I think I mentioned the garage door opener at my mother's home where I replaced the plastic gear in it. That was just a simple injection molded gear, but that's not the only type of gear, not these cheap throwaway gears that you'll find in inexpensive power tools and so forth. There are industrial plastic gears, and they're made possible by the development of materials, basically high-strength composite plastics. Now, because of the way that they're made by injection molding, they can be made economically. And there are improvements on molds, basically, so you can produce more accurate gears. Now, the advantages of these things, of course, are cost. They're cheap. Plastic is a cheap material to make things of, assuming you need many of them. If you make one item out of plastic, the mold itself will drive the cost out, ridiculously. But if you can spread out the cost of the mold over a long run and a large number of parts, then plastic is a great inexpensive material. It's naturally corrosion resistant to usual things like salt water, etc. But one thing you need to be aware of is something called chemical compatibility. I probably should include a chemical compatibility chart in my lecture at this point, but I didn't think of that till now. So pause the video and go look up a chemical compatibility chart. And what you'll find is that some plastics are impervious to some things and then very sensitive to others. So there's basically, most of these charts will give you a sort of a compatibility rating between the particular chemical and the material in question. And typically it's plastic materials. So, of course, many plastics are not good with very high temperatures. That's what steel does well, right? I mean, if you've got something flowing at, 600 degrees Fahrenheit or something, there's not many plastics that can take that kind of temperature. But, of course, if you're injection molding plastic gears, then they'll be relatively uniform. You don't have to machine them, so it saves time. They're quick. That contributes to being quick and inexpensive. And typically, either no lubrication is required or you use a solid lubricant with plastic gear. Some plastics are so-called self-lubricating. There's even bearings made of plastic that are self-lubricating. Of course, these bearings don't take as high loads typically as a steel or ceramic bearing can take, but for the right application, they're very cost-effective, very useful. They can wear very well and serve the same purpose that a more expensive steel or ceramic bearing, or in this case, steel or cast iron gear, or even aluminum gear could take. Also, plastic gearing is relatively quiet. There's less, as the teeth engage, there's less clanking basically between the surfaces because the surfaces simply aren't as hard. Now, of course, the cons, the things against plastic gearing, they don't carry as much load. Plastic simply is not, even composite, is not as strong a material as metals, particularly steels. Molds for these gears are typically not as accurate as a machined gear. So the tolerances you can hold in a mold of plastic is lower than what you can get with machining. Another big con is that many plastics have quite large coefficients of thermal expansion. So as the temperature of the gear or the environment that it's in changes, the gear will expand and shrink much more than the equivalent metal gear would. So they're less environmentally stable and operate over a narrower range of temperatures. As to lubrication, it's required whether you're talking about a plastic gear or a metal gear. As I said, some plastics are self-lubricated. But lubrication is required for steel gears, aluminum gears, anything you might have, because, as I said, there's not just rolling of the gear teeth on each other, there's significant sliding. And so the oil helps, or the lubrication, helps prevent tooth wear. Typically will cool the gearing down if it's in an oil bath and quietens the operation. There's many different possible ways to lubricate gears. One is just a simple splash lubrication, but of course, if you splash it too much at high speeds, you can entrain air in the oil and generate foam. So there are even oils with anti-foaming agents. If you change the oil in your car, it has an anti-foaming agent in it. Fuels typically do to it as well. Oil pumps can be used to move lubrication around if the gears are being lubricated with oil. And grease is also a possibility. Now, one thing you may not know about grease, grease is essentially an oil and a soap mixed together. So it thickens it up, and basically the soap holds the oil in place until a high enough temperature is reached where the soap thins out a little bit and releases the oil. But grease is good for low-speed operation because, basically the grease holds the oil in place. But at high speeds, of course, it just gets slung off. Now, there's also solid lubrication. Solid lubricants can be used with plastics, and that's what usually is used with plastics rather than oil, because oils and petrochemicals commonly will interact with plastics in undesirable ways. That's not always the case, but that's fairly common.